Assalamualaikum warahmatullahi wabarakatuh. My name is Amar bin Yaakob and I'm from Group 11. Today I'm going to present about Taiwan Qingshui Geothermal Power Plant. So this is our group member, Lim Errol, myself Amar bin Yaakob, Abdul Wafi bin Hamzam and Muhammad Asyik bin Suhaimi. So for introduction, geothermal energy, combination of thermal and geothermal. Geothermal resources are underground surface of hot water located beneath the Earth's surface. They may occur naturally or be artificially created and exist at various temperatures and depths, used for electricity generation, heating and cooling system, and direct industrial applications. For the background of power plants, Taiwan is located at convergent tectonic plate boundary. The Qingshui geothermal field is the largest known production geothermal area in Taiwan. Taiwan's first privately operated commercial-scale geothermal power located in Qingshui. The plant has an installed capacity of 4.2 million. It is owned by a joint venture between Taiwan Cogeneration Corporation and Fabulous Power Co. The plant uses geothermal technology supplied by Ormat Technologies. The reservoir temperature is approximately at 180 Celsius.
So next, the objective of this project is to analyze the efficiency and power output of the ORC. Second is to calculate net power output, thermal energy input and heat rejection. And the last one is determine entropy, generation rate and evaluate thermodynamic losses. Next, I want to talk about specification of Taiwan Qingshui power plant. This is their system specification. First is geothermal water inlet temperature is 180 degrees C. For geothermal brine injection temperature 100 degrees C. For isobutane working fluid flow is 41.5 kg per second. And next is water specific heat capacity equals to 4.2 kilojoule per kilogram times Kelvin. Next is working fluid flow rate equals to 11.67 kilogram over second. And the last one is ambient environment equals to 25 degrees C.
My name is Muhammad Asyik bin Suhaimi. My metric number RM24153. So next I will present about working fluid isobutane stage. The fluid undergoes a complete phase change. It starts as a superheated vapor at the turbine inlet and transition into a saturated liquid after the condenser, before entering the evaporator again. In terms of pressure, the system operates on two distinct levels. The high pressure zone is at state 1 and 4, which represent the high pressure required before entering the turbine and evaporator. Meanwhile, the low pressure zone is at state 2 and 3 during the expansion and condensation stage. Highest temperature, the temperature peak at state 1, turbine inlet, where the fluid is at its hottest before it expands to the world. While looking for highest enthalpy, the maximum enthalpy is also recorded at stage 1, since the superheated vapor carries the highest energy content in the entire cycle. For entropy, the highest entropy peak at state 2, turbine at Z, which reflect the standard behavior of fluid expansion in the system. And in conclusion, state 1 is where our fluid is at its highest energy state, having the highest temperature and enthalpy, which is exactly what we need right before it enters the turbine to generate power. So next, I will present about assumption for calculation. First, regarding the system behavior, we assume a steady state condition where all fluid flows smoothly. There are no frictional losses and no fluid leakage into or out of the system. We also assume that the pressure remains constant across the heat exchanger. Second, in terms of energy and environment, the power consumed by the pump and fans is assumed to be constant. The cooling water used is treated as pure water with a specific heat capacity of 4.2 kJ over kilogram. And finally, the surrounding ambient temperature is kept constant at 25 degrees Celsius. These baseline assumptions are crucial because they allow us to establish a clear and controlled environment for our formula and calculation.
So now let's look at the power plant diagram. The one on the left is typically the design of Qingshui geothermal power plant, and the right shows the operation of a geothermal power plant. So basically, the hot water and hot steam will follow the pipe from underground up until a heat exchanger. Then at the heat exchanger, the fluid on the other side will be heated up and turned into gas. The fluid used in the other side for Qingshui power plant is isobutane. So at that, isobutane will be heated up and transferred to and go to the turbine, then the condenser, then back to the heat exchanger again. So what about the heat and steam after the heat exchanger? It will straightaway go back to underground once again. Okay, so here are the simple calculations we did for the power plant, but before going any further, I need to notify that the parameters set here are gotten from the reports created by the inspection team in Taiwan. So let's look at the net power output first. So Qingshui geothermal power plant claims that they can generate 4.2 megawatts, but in order to maintain the operation of the power plant, 200 kilowatts are used for all the pumps, and 640 kilowatts are the heat remove rate at the condenser. Plus another 360 kilowatts power are consumed at the condenser, so which gives a total auxiliary power in 1.2 megawatts. So the net power will be 4.2 minus 1.2, which is 3 megawatts. So next, the thermal input. So the heat source of this Qingshui geothermal power plant are underground hot water and steam mixture. So in order to know how much heat inside, we need to know the mass flow rate, the specific heat capacity, and also the inlet temperature of the water. And we assume that only water is entering into the system for easier calculation. So we get a final input power of 8.82 megawatts. Then the power consumed by the auxiliary system, which is two pumps, one for hot water, the other one for the isobutane. Next is the cooling system, which consume of 360 kilowatts. So in total, 500 kilowatts. Okay, next, stack gas losses. So Qingshui geothermal power plant doesn't have stack gas losses because they use a technology called binary cycle technology that is invented by the OMAD. So this is technology suggests a closed system with very tight of sealing that avoids the potential leaking of any fluids. So it utilizes both liquid and gas to generate electricity. So as a result for it, the stack gas losses are zero at here. Next, the rate of heat rejection at the condenser Qout. So this one is typically written in the report already, which is 640 kilowatts. So Qingshui geothermal power plant use an organic Rankine cycle to generate as the system to generate electricity. So let's look at the diagram on the left. Start from the point at top right. So at the turbine inlet, there are 2.5 megapascal. The pressure is 2.5 megapascal. Then, after passing the turbine, it drops until 0.4 megapascal. So then the isobutane enters the condenser cool down until the enthalpy is less than 300. So at this point, the isobutane already reaches the pump and the pump increases the pressure of isobutane, and it goes up until 2.5 megapascal again. Then the isobutane enters the heat exchanger. So at here, isobutane absorbs heat again. The enthalpy rises from less than 300 megapascal up to more than 700 megapascal. So this is how the cycle's going for the power plant. And next, let's look at how much entropy generated by the power plant. So the values at here, we need to refer back to the specification of the power plant, and also Kelvin is used as the unit for the calculation at here. So we use a formula typically for the calculating the entropy of a power plant. So at the end, we get 21.55 kilowatts. Okay, now let's go through everything very quickly. So Qingshui geothermal power plant uses organic Rankine cycle and isobutane as the working fluid. Then it can generate approximately 3 megawatts of power. And geothermal energy is recognized as a reliable and sustainable renewable energy source. So the calculated heat input, heat rejection, and entropy generation help us to evaluate the performance of the power plant. And from the result, we can see that the organic Rankine cycle system has a moderate efficiency, as the technology of geothermal power plant is still not yet fully investigated. I think that's all from Group 11. Thank you, sir, for listening to our presentation patiently. Let's call it a day. Thank you.